This is Group 39 presenting our jump box, the jukebox updated for modern play. Our group members are Julian Vasquez, myself, Jack Wilson, Andre Jennings, and Jacob Reisterer. For our project motivation, we have seen that vinyl record sales have spiked in the past decade, and few options exist to automatically play 12-inch format vinyls. For this, we have made the jump box, which attempts to bridge generations with a combined experience. This also appeals to music fanatics who are looking to elevate their music listening to the next level.
Here we can see some of our goals and objectives for the jump box. Some basic goals include playing at least four different records, playing the A and B side of these records, and the user should be able to control the jump box locally. Some of the advanced goals are the user can control the jump box remotely, and the record setup is quick and smooth. Some stretch goals we have is that there's a visible and interchangeable queue for the records, and the record storage module can be interchanged for quick swap outs. So here are engineering specifications. Overall, we have the touchscreen UI response time being less than a second. Some robotic system specifications are maximum movement speed of greater than 10 centimeters per second and maximum vinyl change time of 90 seconds. So mobile app specifications are the response time of the remote control being less than 2 seconds.
Here we have some clips of the jump box in action. At the bottom, you see that timer counting up. That's counting the seconds it takes for one vinyl to come off of the turntable and for it to be replaced by another vinyl. That's one of our specifications that we're attempting to reach. As you can see, that end effector right there, that little gripper, has successfully picked up the vinyl, and now will take it safely over into its storage area. Overall, the construction of our jump box has 3 stepper motors and 4 servo motors. At the top, we have that X-axis that's going left and right, and then we have a Z-axis that's going up and down. That enables us to have motion like that. And as you see, that record was successfully placed back into storage, and now it is moving to pick up the next record. Some other things to note is that we do have those nice laser engraved pieces of wood to frame our jump box done by Jack, as well as a really well done electrical cabinet on the back that you might be able to see in some later clips. Right here, we're playing the B side of the record, so it does have a flipping motion right there to turn it around, and now just placing it on top of the record player. There is no audio on this clip, or else you would hear it actually whirring around and moving, and you'd also hear the music playing. There are speakers on the jump box. It's fully self-sufficient, so all you have to do is wheel it to wherever you want it to be, and then plug it in, and it will play. And right there, you saw that the tone arm moved over, and it will be dropped on top of the record, and that would be the successful completion of a record swap out, and that took around 85 seconds. Some other things to note is that we did make a custom PCB for this, running through an ESP32 S3. And we also have not one, not two, but 3 custom power PCBs. And right here, we're showing off that local GUI that we talked about earlier. This is a touchscreen. It is currently attached to the frame, but it does have a 10-foot tether that allows it to be mobile. So if you wanted to control it from slightly further away, that's an absolute possibility. And then I'm currently showing off that it is playing a record, and then later on I'll interact with the screen, and you'll see that it does in fact control the jump box and cause discs to be cycled in and out of the turntable. Some other things you can see inside this frame are cable sleeves that are keeping all their cables nice and neat, and there you see that touchscreen command went through perfectly fine. And you might be able to see a little bit more of that electrical cabinet that I talked about earlier. It's kind of hard to still get a good sight on it. But then again, we see everything is fully functional with the jump box. The records and vinyls are all moved securely, safely, and put back into their positions. One thing to note, we do that sliding motion where it places it at the back of the rack and then pushes it forward to ensure that all the vinyls are placed in the same spot.
Moving on, we have some of our mobile information. The first button I set here was just an auto home function. So we're trying to keep our position data relatively up to date, knowing where that 0 is so we can make all our really precise movements. So it's actually doing some very small micro steps and hitting some bump switches so we can get that information. Then I'm kind of talking about the process imaging. So this is actually how we're going to get the records into storage, which you can see here. And we have a long list of our records. I think I'm going to delete one of the records here in a second. So you can see we have an add function that will show, and you can delete. So I deleted run DMC, and that's gone. We can also search, so we have a search function, and I look up Dire Straits. And then also additionally, there is a favorite section. So we only have 4 album slots, so you can favorite and put them in each slot that they're supposed to go. And you can see those in the yellow text and with the star. Now, when you want to actually play something off the mobile app, you can add it to the queue. So you can see I'm about to add Queen, I think, side A, right? And it immediately goes and does that maneuver, right? So it's going to lower down and get that. And you can see it has the disc labeled and the side labeled, and then we have a pause and play button, and then a next album button. We've also got the up next in the queue. There's currently nothing in it, so it says that. And it lowers it down all the same. You can actually see that power cabinet Jacob was talking about a minute ago now more clearly. On that left, that is our custom signals PCB. It's got an ESP32 S3 on it. And then to the right of it is our Raspberry Pi. So the Raspberry Pi is handling all of our server and all of our networking information. It's handling all the HTTPS requests for the app. So anytime that there's something that needs to be processed there, it's going to the Pi first. And then through serial communication, the Pi is talking to our ESP. And the ESP is handling the actual physical queue itself. So it's keeping track of what's actually on the record player at one time. We wanted to do this to separate the two. So we can actually have the communication scheme working a little better, not have them running over each other. So you can see I just skipped Queen, and this goes to start the pickup motion, okay? So this is all automatic. It's all on the back end and through the ESP Arduino commands. So as it returns it, it's going to put it back down and then grab the correct one, disk 3, side A, so that's Kids See Ghosts. And it's going to start that movement. And again, a lot of this frame was cut with MDF wood. It was all laser cut. You can see our group name into the side, and obviously our whole platform is kind of built out of this. The rails are all aluminum V-slot rails. It's about 1,000 meters off the ground and about 600 long, I believe. And so that pops onto place. And so next we'll demonstrate our album recognition system. This is all done with the Google Cloud API, so they have a very nice vision system. There's a couple different versions or a couple different test demos you can do. We're using the web results version. So what we do is we take so I've got Born to Run, which is Bruce Springsteen, and I'm going to process this image. And so I set it on the table, and I'm going to take a photo. This opens up my camera, and you can see I take a photo of it and press OK. And then I'm going to crop it down to size. We're going to make it square and click Done. And so this opens up actually a couple of keywords here. So you can see we have Born to Run Bruce Springsteen album, Born to Run album cover, East Street brand, right? So we have a couple different results. So what this is actually outputting is the top 10 web results from the Google API. And then there's also at the bottom a manual search button. So if this doesn't actually get the results you're actually looking for, you can manually search, and that is with an album and artist lookup. And so when you click one of these buttons or you do a manual search, this is actually passed through to the iTunes API. So I'm going to do that now, I think, here. So I click Born to Run. And it instantly pops up. So it's populated with the results from the iTunes API, and then there's also a store album info. So this is actually how we can get it into our database, and you can see the tracks and their lengths, and we also get a little cover art of the album to make sure we have the right run. So we click Stored, and we click OK, and the top right there's a thing that takes us right to our library, and you can see now that we actually have Born to Run in our library. So this was the jump box. This is our demonstration. Thank you.